Okay, so for our next section, section 2.3, we're still going to be dealing with using some of the basic operations that we did in section 2.1, solving the linear equations, except in section 2.3, we're going to now be what we call solving literal equations. Now, another way of saying this is that we're going to be solving formulas. Now, when we were solving the linear equations, we got it down to x equaled 7, x equaled to negative 3. We got maybe x equal to half. We did see those two special cases. Remember that if the variable x cancels out and you're left with a true statement, that's when we wrote x was all real numbers. Or if the variable x canceled out and you were left with a false statement, that's when we talked about no solution. But here, when we're solving formulas or solving what we call literal equations, your answer is not going to be a specific number. Your answer is going to be some type of algebraic expression. Okay? Let's just look at some basic examples. All right? For example, let's say we are given x plus y equals 8. This is an example of what we call a literal equation, a formula of such. Because what we have here is multiple variables, an x and a y, and there's a distinct relationship between them. Now, when you're asked to solve a literal equation, not only are you going to be given an equation, but you will be told which variable you're trying to get by itself. So, for example, given x plus y equals 8, I could tell you to then solve for x. And if we're trying to get x alone, that means we have to eliminate the y, okay? Kind of like in step 3 of solving the linear equations, y is acting like the constant. And that in order for me to get rid of the y, I'm going to have to subtract y from both sides. And when I do that now, we would have x equals 8 minus y. So we have, in essence, solved for x, but what we are left with here is not just a specific number, but an algebraic expression. Now, I could have given you the same exact formula, the same exact literal equation of x plus y equaling 8, except now, of course, I could ask you to now solve for the variable y. And so if we have this same relationship, except now I have to get y by itself, I have to eliminate the x. So I'm going to subtract x on both sides, in which case now we would have y equals 8 minus x. So with literal equations, you are going to be given some type of relationship, but then you also need to be told which variable you're looking to solve for. Okay? That's the variable you want to get by itself. Let's do some other ones involving this solving literal equations. Let's say we have 2x plus 4y equals, let's say, the number 10. And let's say, once again, I want you to solve for the variable x. We're trying to get this x term by itself. Well, to get the x term by itself, I have to eliminate this 4y. So I will subtract 4y on the left, and I have to subtract 4y on the right. Now here on the left side, 4y and the negative 4y will cancel, and that would leave us with a 2x equals. On the right side, we would have 10 minus the 4y. We can't combine these two terms on the right side because these are not like terms. So now, we are still looking to get x by itself. We don't want 2x, we want just 1x. So we're going to have to eliminate and divide both sides by 2. Well, here now on the left, 2x divided by 2, that's x. Here on the right side, when I take the 10 and divide it by 2, we get 5. And if I take the negative 4y and divide it by 2, we get a negative 2y. And that would be your solution. Okay, you have gotten x all by itself, so you have solved that literal equation. And once again, you are left with some algebraic expression. Okay? Let's try another one. Let's say we have 4x plus 2y equals, let's say, the number 3. Except now, once again, I'm going to ask you to solve for the variable y. We want to get the variable y all by itself. So the first thing that we would have to do is eliminate the 4x. So I'm going to subtract 4x on the left and on the right. Here on my left side, 4x minus 4x will cancel, and we have a 2y equals, here on the right, 3 minus 4x. Now we don't want 2y, we want just 1y. So what am I going to have to do but divide on the left by 2? That means I have to divide on the right also by 2. Well, here on the left, 2y divided by 2 is just y. Let's simplify what we can here on the right side. Can't do anything with 3 halves, so let's just leave it as such. 3 halves minus 4 divided by 2, that of course would give you a 2x. And that would be your solution for y. Now, maybe you've taken other classes, not necessarily math classes. Maybe you've taken a business class. Maybe you've taken a chemistry class. Maybe you may recall back in high school you took a geometry class. And in those classes you encountered many different formulas. Okay? For example, maybe if you have taken accounting or in a business class, maybe you have seen the formula that I equals PRT. Okay, this is a very common formula in the world of banking and finance. And what this formula is basically talking about is that the interest I that you earn on an investment equals the principal, that's what P stands for, which is the amount of money that you are investing, times R, which stands for the rate, times time, which is how long you are making your investment for. So here we have a classic formula from the business world. And here, if I equals PRT, I could ask you maybe to solve for the variable, let's say, R. I want to get the variable R all by itself. Well, we can do so in one quick step. I look at what's happening with the R. The R is being multiplied with P and with T. And to eliminate multiplication, what do we have to do? We have to divide. So what I'm going to do is I'm going to divide both sides by PT. Because on the right side, P divided by P would simplify, and T divided by T would simplify. So on the right side, we have just the variable R equaling I divided by P times T. And that would be your literal equation, your formula, solving for the variable R. Okay. Another formula, maybe I believe it's from chemistry or physics, I'm not quite sure, but I do recall a formula that PV equals nRT. Okay, that's another formula from another class. And let's say, once again, we want to solve for, well, once again, maybe let's solve for the variable r, okay? The little r, not the big R. Nope, the formula is wrong here. It was PV equals nRT. That's the formula I'm thinking of. Let's solve for the variable n, okay? To solve for this variable n, once again, what's happening to the n? It's being multiplied with the r and the t. So to get n by itself, we would have to divide both sides by RT. So now we would have n equals PV over RT. That would be your answer. You may recall from geometry, okay, thinking back to when you first learned about some geometric shapes, maybe you saw the formula that P equals 2L plus 2W. You may recall that this is what we call the perimeter. This is the formula for the perimeter of a rectangle is equal to 2 times what we call the length plus 2 times the width. That's how we find the distance around a rectangle. That's what we call the perimeter. And if we have this formula, let's say I might ask you to solve for the variable L. Okay, to get L by itself, okay, what we need to do initially is to eliminate this 2W. Since 2W is being added, I would subtract 2W on both sides. Now here on the left side, I would have P minus 2W equals, on the right side, we're going to have simply 2L. But we don't want 2L, we want just 1L. So to eliminate the coefficient 2, I'm going to divide both sides by 2. And then I'm going to simplify. Well, 2L divided by 2, that is simply L. Here on the left side now, P over 2, can't do anything with that, minus, here 2W divided by 2, well the 2's would simplify, leaving me with just W. So L is going to equal P divided by 2 minus W. Let's try another one. You may recall, also from geometry, that V equals 1/3 pi r squared times h. You may have seen that formula before. And this is a formula in geometry that we use to find what we call the volume of a cone. The volume of a cone is equal to 1/3 pi times r squared times h, where r is what we would call the radius, h is the height of the cone. And so if we have this formula, I could ask you to, let's say, solve for h, the height of this particular cone. Well, one thing that we can do first of all, maybe is, since a lot of people are not a fan of the fractions here, like 1/3, okay, to eliminate a fraction like here, the 1/3, what we can do is multiply both sides by the reciprocal, and the reciprocal of 1/3 is 3. And if we multiply the 3 with the v, we would of course get 3v on the left. On the right side, if we multiply the 1/3 with the 3, whenever you multiply reciprocals, you always get the number 1. So now we would have pi r squared h. Now we're still asked to solve for h. And once again, in looking at h is being multiplied with pi and with r squared. So to eliminate the multiplication, I would have to divide both sides by the pi r squared. And so now the pi's would simplify on the left, on the right, as well as the r squares would simplify on the right, leaving us with h equaling to 3v divided by pi r squared. And that is your value for h. Let's just try one more, okay? A little bit more challenging. Also a formula from geometry. The formula is that a equals 1/2 h times b sub 1 plus b sub 2. Okay, here's a very well-known formula. You've probably seen it before. It's the formula that we use to find the area of the two-dimensional shape of a trapezoid. Okay, and what is this formula telling us? That by taking half the height of the trapezoid and multiplying it with the sum of the bases, you can get the area of the trapezoid. And let's say we wanted to solve this formula for maybe b sub 1. Okay? So, once again, like the previous example, let's maybe first of all get rid of that fraction of 1/2. So let's multiply both sides of the equation by the reciprocal 2. And in doing so, on our left side, 2 times a would of course give us a 2a equals, when we multiply the reciprocals 1/2 and 2, that gives us just h times b1 plus b sub 2. Now, here, remember, our goal is to get b sub 1 alone. Some people, what might they be inclined to do is to distribute the h. Okay, and you could do that, but you don't need to here in this particular case. Let's get rid of that h on the right side. How can we do that? Well, since h is being multiplied with the parentheses, remember, to get rid of multiplication, what you always have to do is the opposite, division. So we would divide both sides by h of the equation. On the right side, the h's would simplify. So the left side would now read 2a divided by h equals b sub 1 plus b sub 2. Now we're almost there. Remember, to get b sub 1 alone, the last thing that we would have to do is to get rid of that b sub 2 term. Since it's being added, once again, we always look to do the opposite operation. So I will have to subtract b sub 2 on both sides. On the right side, the b sub 2 terms would simplify, leaving us now with just b sub 1. And what is b sub 1 going to equal? Well, on the left side, we have 2a divided by h minus b sub 2. So once again, as we solve these literal equations, as we solve the formulas, you will be given the relationship, as well as you will be told which variable you are looking for. Your answer will, once again, will not be a numerical answer, but some type of algebraic expression. Okay? That completes section 2.3. Okay? Once again, there is some practice problems. Try those problems for homework and email me with any questions that you may have. Until the next time, be well.